we're going to dive into lesson 3.4, and what we're going to do is, so yesterday we learned all about factoring a polynomial function. We used the factor theorem first to figure out which one is the first factor. Then we used synthetic division to factor that first binomial factor out. Now, don't get flustered by the word linear factor, okay? So that was probably a word in the quiz today where people are like, Mrs. Aguirre, what did you mean by linear factor? It just means that the factor that you got, the binomial factor, where I say like, oh, x minus 2 is a factor, it just means it was a degree 1 factor. Like here, when I'm looking at this example, this right here is a linear factor because it's degree 1. This right here is a quadratic factor because it's degree 2. So if I'm saying, hey, factor this polynomial to linear factors, you should have like basically 3, if it's cubic, you should have 3 linear factors multiplied. Does that make sense when I say that? So if the word linear factor flustered you, don't let it. It just means it's a degree 1 factor. Okay? So now we've got to put, we've done the factor, but now we've got to put all the details together. And this is the last detail that I need you guys to know. And this is a detail that I want you guys to recognize as, this is a critical detail that you would add to your study notes. Like this is not something you would just like slip over and say, like, I'm going to remember this in June. You're going to forget it. Lots of people forget it. Okay. When you look at this, we know that this is a cubic function. If a graph goes straight through the x-axis, each of these x-intercepts would be considered a multiplicity of 1. What that means is that factor appeared only once in the factored form. Okay? So multiplicity of 1. So we've got 1, 2, 3 x-intercepts. Each of them are multiplicity of 1. So 1, 2, 3, and it adds up to a cubic function. This is what multiplicity of 2 would look like. So if I've got like an x-intercept of 2, and if I wanted to bring it back to the factor, then the factor of x minus 2 would have to be taken to the power of 2. So when you see multiplicity of 2, that factor had to be taken to the power of 2. Okay? This one, like if this was like a 3, then the factor x minus 3 was actually just taken to the power of 1. If there's nothing there, it's assumed to be 1. Right? Like, so that's what multiplicity of 1 looks like. This is what multiplicity of 2 looks like. So this is multiplicity of 1. Okay? Here, I'm just going to get rid of this and this. If this is multiplicity of 2, and this is multiplicity of 1, well, 1 plus 2 gives me 3. So remember when we were sketching and I was like, hey, draw a quartic function with 3 x-intercepts? You guys always kind of recognize, oh, I'm going to have to bounce off the x-axis because I don't want 4. I want to see 3 x-intercepts. You had to show me a multiplicity of 2, and when you add this up, we still get our cubic function. This little, like, bend in the road, okay, this is multiplicity of 3. This is what multiplicity of 3 looks like. And it's just like a little jog in the road, but then you carry on in the same direction. It's like a pause for a second where for an instant you've got a slope of 0 and then you move on from there. Okay? So in calculus we'll talk about like for just an instant we have a slope of 0 and then we move on. And a slope of 0 is like a horizontal line. For just a second, so we've got like positive slopes, and then you've got a 0 slope, and then it's like you're basically going uphill. But there's just a pause, and that's what multiplicity of 3 looks like. So in this particular case, if it was at x equals 0, we would say x to the power of 3. This is the factor you get when your x-intercept is 0. It's just x. There's no number associated with that. Does that look okay? So, but I'm interpreting this. This would be considered a multiplicity of 1. This is considered a multiplicity of 1, and this is considered a multiplicity of 1. 1, 2, 3 adds up to be a cubic function. You guys see that? So when I look at this graph, when it says the least possible degree, that's language I need you guys to not feel flustered by. So when you come in and I say least possible degree, technically if this graph went on forever, there could have been further bends making it like a degree 5. Okay? But from what we can see, what's visible right here, we know it's degree 3. So don't get flustered by the least possible. Just from your multiplicities, if this is multiplicity of 1, this is multiplicity of 1, and this is multiplicity of 1. I just want you guys to add your multiplicities to get your degree. So this is going to be degree 3. Guys, what's the sign of the leading coefficient? Brody, how'd you know? It's going uphill, right? We're going Q3 to Q1. Okay? Now, what we're going to do, and you can't say that this is your equation. It's not just x-intercepts that make a polynomial function, but just all we're going to do is we're going to grab the x-intercepts, x equals -4, x equals -3, and x equals 2, and we're going to bring them back to the linear factors. This is not my function though, okay, because there's always going to be a potential stretch factor, like a vertical stretch by a factor of, that's always going to be part of our polynomial function. So all I want right now is just the linear factors. Now listen to the language I'm using, linear factor, which that means it's just a degree 1 factor. That's it. So don't let the word linear factor fluster you. Okay? Can I get you guys just to handle this guy? Notice that it's all the x-intercepts are multiplicity of 1. We actually went straight through, straight through, straight through. Sarah, what do you have here? What's my least possible degree showing? These 3 x-intercepts, this is a multiplicity of 1 for all 3 of them. So 1 plus 1 plus 1 gives me 3. So this is degree 3. Yeah? What's the sign of the leading coefficient here, guys? If we are going from Q2 to Q4, we're going downhill clearly. Adelaide, what would this be? Negative. Now, from the x-intercepts, I've got x equals -4. I've got x equals -3. I've got x equals -2. What would my factors, what would my linear factors be? Brody, what do we have? Okay, so Brody's taking it. This is exactly where I want you guys to go. I want you guys to recognize that the only way that we could have gone downhill is if we would have had a negative leading coefficient, and we know that, right? There's no way that just these factors alone, without a negative leading coefficient, will give us that graph. So Brody right away was like, okay, P of x is equal to, and I love that he added this right away, because this is what we're going to algebraically determine later, okay? And then what's the other factors, Brody? Okay, so all I was actually asking for were the factors associated with the x-intercepts, but I actually want you guys to start writing like, oh, this is the polynomial factored form, but I haven't found the a value yet. We're going to get into finding the a value shortly, okay? So, okay, so this is a little bit different. First of all, what degree is this? Like when you look at the graph, I see that it's opening up, which means it's an even degree. It's not a parabola. This is degree 4, okay? So, but this right here, this is multiplicity of 2. This right here is multiplicity of 1. And this is the last detail that I'm teaching you guys. 2 plus 1 plus 1 gives me 4. So now when I add my multiplicities, okay, we're going to have 4. And in this course, you're not going to have crazy bends later on. You just look at the graph that's showing, and you assume that there was no other crazy like bends or turns or anything. So least possible degree, from what I can see, this is degree 4. The sign it's opening up, right? So this is Q2 to Q1. So we know that it's positive, it's opening up. Now watch this. If I say my x-intercepts, x is equal to -6, x is equal to -3, x is equal to 1. This one right here was multiplicity of 2, and this is how we handle the multiplicity of 2 factor. When I bring it back to x plus 6, I square it. That's it. That's what you do with multiplicity of 2. And then I've got my x plus 3, my x minus 1. Now technically, if you add the exponents on your factors, you should also get degree 4. And we are going to throw an A in there because I'm not certain, like I don't have the whole function yet. I just have my variable factors based on the multiplicities. Does that look okay? So now we're going to find the equation for the graph presented. Okay? So right away, from the x-intercepts and including the multiplicities, I know that this is Q2 to Q4, so it's an odd polynomial function that's going downhill. So I know I have a negative leading coefficient. You guys get that, right? You see it? We know we have a negative leading coefficient. So this is telling us that we do have a y-intercept of 0 and -4. It wasn't clearly indicated as a dot here. But all I'm going to do is I'm going to grab my x-intercepts. I've got one at -4, and I've got another one at 1. But this one is multiplicity of 2. So from my x-intercepts, I'm going to bring it back to the factors. But I have to remember that the x minus 1 was multiplicity of 2, which means we had to square that factor. Okay? Now, Brody made a point of saying, okay, we have an A value. This is when you guys are going to use your algebraic reasoning to algebraically determine A. Okay? So I'm going to give you some other point. And in this particular case, I gave you the y-intercept. Now guys, a constant term never belongs in factored form. Factored form is something, expanded form is constant term. A lot of people are like, oh, I want to go minus. That's not a thing. Do not put a constant at the end of a factor. It's either factors or nothing, right? Like it's either expanded or factored. So your y-intercept does not just tack on to the end here, okay? Your y-intercept is the ordered pair that you're going to use to algebraically determine your A value. So I have the gift of an ordered pair that wasn't an x-intercept. My x-intercepts have already been used. You can't use them again. I'm going to put the -4 in for the y and the 0 in for the x. And I'm going to algebraically determine the A value that would make my function go from quadrant 2 to quadrant 4 and go through this specific y-intercept. So I'm going to do the algebra. If you've been given the gift of an ordered pair and you're missing something like the stretch factor, 0 plus 4 is just 4. 0 minus 1 is -1. -1 squared is 1. I can see that my A value was -1. And now I have to put all the details together. I don't know why I boxed this. I think I just wanted to get attention, like bring attention to it, because that's not the final answer. So my final answer is P of x is equal to -1, x plus 4, x minus 1 squared. So at this point, you would never develop the equation of a function without typing it into your calculator and looking at it. Like that would be silly. If you've been given a function, look at the function. See if your function looks like this. Does it have those x-intercepts? Right? So in my y equals, I put my stretch. So all that happened was we had a reflection across the x-axis, making the cubic function, instead of going uphill, it was now going downhill. So we talk about it like we would any A value, like a vertical stretch by a factor of or reflection across the x-axis. What were my factors? I don't remember. What were the factors?
X plus 4. X minus 1.
I lost my x. X plus 4. Oh, why? X plus 4. And then?
X minus 1 squared.
Okay. Okay, I'm just going to trace a couple numbers. If I trace -4, I've got my x-intercept. When I trace the 1, I can see the multiplicity. When I trace 0, I can see that I went through the y-intercept at 0 and negative. If you forgot the A value, like if you forgot, that, like if you just did factors, okay, does that go through a y-intercept of 0 and -4? Does it have the same end behavior? You're always always going to have to find the a value that would either reflect the function across the x-axis or stretch it to go through a particular y-intercept or any ordered pair. Okay? So this right here, so this at x equals 3 here, this is what multiplicity of 3 looks like. So I've got x equals 3, I've got x equals -4. If I'm going to bring it back to the factor, so x equals -4, x equals 3. Bringing back to the factor, we've got x plus 4, and then I've got x minus 3, and this is multiplicity of 3. Just don't forget that there was a potential stretch factor. You actually have to show, even if the stretch factor was 1, you actually have to show the algebra to get that 1. Like, you can't just say, like, oh, here's my factors, it went through everything I needed to. You actually have to justify that there was no reflection. I know that a is positive because it's a quartic function opening up. 3 plus, this is multiplicity, sorry, 3 multiplicity of 1, and then this one was multiplicity of 3, multiplicity of 1 adds up to give me 4. And now I have to pick another point. This is an x and a y. It's not a constant at the end of the factor. It becomes the x and y. So I've got -10 is equal to a, 0 plus 4, 0 minus 3 cubed. And this is -27. If you want to, guys, you could just fire this whole piece into your calculator. Like, if you wanted to just let it do the order of operations for you, like you've got your, oh, okay, 0, was it -4 or +4? Was it +4? +4? So you could go 0 plus 4, and then you could have like your 0 minus 3, close the bracket, to the power of 3. Like, you could just fire this into your calculator and you get your -100. You are not going to be able to guess and check that kind of number. So I've got -10 is equal to -108 times a. I divide by the -108. Here, I'm just going to... And this is all multiplication. Put the variable at the end. It just kind of cleans up the details. And what do we end up with here then? Did you guys get 5/54? When you take -10 divided by... Okay, not enough. We now have to put the whole thing together. So, when you're... And then, so again, put p of x back in, put the x's back in. We don't want just the y-intercept. We want the whole function, so the variable x's go back in. And don't forget that this was cubed. If you missed the cubed, you just made it a quadratic, not a quartic. So I'm going to test this. So in my calculator, and again, you're not going to randomly guess and check. So this is a vertical stretch by a factor of 5/54 from the x-axis. That's what the a value did. And that vertical stretch forced it to go through the y-intercept that we got. So I have my 5/54, bracket x plus 4, close the bracket x minus 3, close the bracket to the power of 3. Okay, I'm just going to trace some of these. Trace -4. Was that on the graph? Yep. Trace 0, -10, trace 3, and there's my multiplicity of 3. You can walk away from this question feeling entirely confident, and you know that you've gotten everything. Just notice that we use the y-intercept to find the a value. We don't tack on a constant in factored form. There's no such thing as constants in factored form. Okay. So now what we're going to do is we're going to be sketching this graph. Okay, so first of all, what degree is this? Okay, this is multiplicity of 3, this is multiplicity of 1. Do you guys see that that's going to be a degree 4 polynomial with a negative leading coefficient? Okay, so we got the A value. So if we've got that negative leading coefficient, are you guys okay with Q3, Q4 for end behavior? Like when you first interpret this, when you act, so this is a degree 4, and it's also neg leading coefficient. So that's definitely my start when I'm interpreting the function, even in factored form. Okay, if I say y-intercept, what are you guys thinking? Okay, when you're in factored form, just put the 0 in for the x. So put the negative sign in there, put 0 plus 1 cubed, 0 minus 3. When you plug that, you can plug it all into your calculator if you'd like. Some of you guys recognize that this is actually just negative times 1 times negative 3, which is going to give you 3. Because 1 cubed would just be 1. So I've got a y-intercept, and I'm going to use, actually it's y, so I'm just going to say, I'm going to use this notation because I didn't label it as p of x. So I know I'm going to have a 0 and 3. For my x-intercept, I'll use a different color. For x-intercepts, what am I thinking? Y equals 0. So putting 0, this negative sign does not change the x-intercepts. A reflection across the x-axis has like invariant points on the x-axis. So the x-axis, the x-intercepts don't change. No matter what A is, it will not change your x-intercepts. We just set each variable factor. So this guy is multiplicity of 3, so I know that x plus 1 has to equal 0. So then x equals negative 1. You have to think multiplicity of 3. And I hope you guys can read my writing. And then x minus 3 is equal to 0. So then x equals 3. This one is multiplicity of 1. So I'm going to grab that 3. I'm going to grab the negative 1. I have to start here, but I have to make sure I indicate multiplicity of 3 here. So this is how I'm going to show this. As long as I'm starting in quadrant 3, and then I kind of like do a bend in the road, I'm going to have to go past the y-intercept and then straight through the second x-intercept. This y-intercept wasn't halfway between these two, so it can't be your max. Do you guys get that? You need to, if you're going to draw a sketch, and it's like, I know your calculator gives this stuff to you, but you need to justify it, you need to determine the y-intercept, you need to determine the x-intercepts here. You need to show the algebra to justify it. And right off the hop, you should be saying, okay, multiplicities add up, 3 plus 1, right? 3 plus 1 gives me 4. We're going to ditch this. This is actually part of calculus. And I'm going to make sure that none of the questions on your homework actually asks that. And don't worry, it's not something that you have to do. So now we're going to dive into this guy. And we are going to fully factor this cubic function with the intention of finding the x-intercept. So this one is a little bit more difficult. And then I think I'm going to send you guys to the whiteboards to do it. Okay? So if I want to accurately graph this, first of all, what's my end behavior? What's my end behavior? How do you know? Yeah, you're thinking downhill. So we know we're going to go Q2 to Q4. When I say y-intercept, what are you thinking? X equals 0. So This time it's f of 0. And if you want to show your work, or what did you guys see about the function? Like, do you guys recognize that you can see the y-intercept here? Because this was expanded form this time, and in expanded form, the constant gives me the y-intercept. Yeah? Now we're going to start by factoring this expression. How many of you guys like to factor functions that have like negative signs in the front? Like, does that bother you guys at all? Okay, so maybe it doesn't, so let's not worry about that. If it bothers you, you could factor a negative out of every term and then work with that cubic function if you wanted. Let's not go there. Let's just start factoring. So yesterday we practiced factoring cubic functions. And we were asked to sketch this, so can I get you guys to type this into your calculator? Type this into your calculator, tell me what it looks like. What's your first x-intercept that you see? What nice, neat x-intercept do you guys want to dive into? Which one do you want to use? -2? Okay, let's use -2. Okay, so what did we do yesterday? We fully factored these expressions. So when I put f of -2 in, when I put that f of -2 in, you do get 0. What does that tell you? This is an x-intercept. And the factor associated with that x-intercept is x plus 2. So now we're going to take our f of x, and we're going to divide it by the x plus 2 to see what we get for the remaining quadratic factor, right? So we take the root of the divisor, and I take all the coefficients of the cubic, so -2, 3, 11, -6. It went 3, 2, 1, 0, so carry it down. And then we bring back the factored form. So I've got my first factor is x plus 2. And then I've got this. I've got -2x squared plus 7x minus 3. And because we had more x-intercepts showing, and we had another one that was actually an integer, I know that this is factorable. But what people often make a mistake with is this negative guy, so just be careful. -2 times -3 gives you a product of 6 and a sum of 7, which is going to be 6 and 1. Yeah? And so you do have to show me, like, all of the work that goes into you coming up with those x-intercepts. I'm going to decompose this middle term, and I've got -2x squared plus 6x plus 1x minus 3. I'm going to GCF the -2x out. Are you guys okay with that? And because if I take the negative out, it's going to become positive negative. This guy is just going to be plus 1. When I take out the -2x, I'm left with x minus 3, and then plus 1, x minus 3. And so fully factored form for f of x would be x plus 2, x minus 3, and then the last one is -2x plus 1. We had that negative leading coefficient, so we do have a negative sign on one of the factors. Now, some people factor this negative out and they put it way out in front right at the beginning, and then they would have called this 2x minus 1, but you should be okay either way, okay? As long as you recognize, oh, there was a negative x term on one of the linear factors, okay? So now that I have all these details, I still have to find the x-intercept. So after I've done all of this work, I need to find my x-intercepts. So if I put the 0 in and set each factor equal to 0, I have x plus 2 equals 0, x minus 3 equals 0, and none of them have like a fancy multiplicity or anything, so they're all going to have multiplicity of 1. So x equals negative 2, x equals positive 3. I'm just going to move the 2x to the other side, making it positive, and then I'll divide by 2, and then x equals 1/2. And I'm just going to take a look at the graph. Does it look like x equals 1/2, positive 3, and negative 2? But your algebra has to justify all of that. So, all of the work, like your y-intercept of 0 and negative 6, is indicated. I know that I have to go Q2 to Q4, so I know I'm going to start my pencil here and I'm going to finish my pencil here. But I also have like the graphing technology that I could be looking at as well. And they're all multiplicity of 1. So just make sure, notice this is not halfway between these two x-intercepts. Make sure you go lower than the y-intercept. So I'm just going to make sure it's multiplicity of 1, lower than the y-intercept. Now, where those turning points happen, that's calculus. So we're going to find where, like, the slope basically turns 0 for an instant, and then you've got your sketch. But you had to algebraically determine the y-intercept. You had to algebraically determine the x-intercepts. We're not going to worry about the intervals for which it's positive or negative. I'll take those out of the homework. Okay. Now, does anyone have any questions about how to fully algebraically graph a function? Okay, go to LifeWorks.